chapter 8 and chapter 9. So this is our last
Tuesday.
section we are doing today. So what is section 9.3 is, it's about complex plane. It's about complex plane, complex number. So it says if r is greater than 0 and my theta is between 0 to 2 pi, the complex number, note my complex number is z is equal to x plus I y. It's x plus whatever you have with iota, I is your y. So it's x plus I y may be written in polar form as, z is equal to x plus I y is equal to, x is basically r cosine theta, which we did before, and we know y is r sine theta. So basically it becomes r, if I take out common, it becomes cosine theta plus iota sine theta. So basically my z is equal to r cosine theta plus iota sine theta. Very important here. So if you are given this thing, complex number, and I say convert into polar form for complex. For complex number, if you have to convert into polar form, this is how you convert. The formula is z is equal to r cosine theta plus iota sine theta. Example. Example how you're gonna do is, let's see here. It says write an expression for z is equal to root 3 minus I in polar form. So you need to write this in polar form. Okay. Can I have Eduardo?
Yeah,
Okay, Eduardo. What's my x and what's my y?
your x is going to be root 3 and your I is going to be -1.
Negative 1. Perfect. Do you know a formula where I can relate my r, x and y? Do you remember we've been using a formula? How do I find my r if I know my x and y?
Wait, sorry, you're cutting off on me.
So there was a formula we've been using for finding r when you're given x and y. Do you remember that formula? Or no?
Don't we use the sine formula?
No, we use x square. Remember, x square plus y square is equal to r square.
Yeah.
Yeah, we've been using this to find, if you know your x and y and you have to find your r, this is a formula we've always been using. We'll still use the same formula. So you have, it becomes root 3 square plus y is basically -1 square is equal to r square. We get 3 plus 1 is equal to r square, which implies 4 is equal to r square. Take square root. I'm just going to consider the positive one. Since my radius cannot be negative, you get r is equal to 2. R is equal to 2. Now I need to figure out what's my theta. Anyone can tell me how to find theta? No? So sine theta, the formula is y over r, which is equal to y is -1 over 2. Cosine theta is basically x over r, which is root 3 over 2. Can anyone tell me for what value of theta is my sine -1 over 2 and cosine root 3 over 2? Anyone?
The the cosine of root 3 over 2 is going to be pi over 6.
Yeah, but then I need sine also as negative 1 over 2. It should be both these conditions. Sine should be negative, cosine should be positive.
Okay, wouldn't that be 5 pi over 6?
5 pi over 6? 5 pi over 6.
Or no, pi over 6.
See, let's see
No,
here.
no, sorry, 2 pi over 3.
Let's see here, Eduardo. Let's see here. So, first of all, cosine positive, sine negative. Which quadrant am I talking about?
Talking about the second quadrant.
Cosine positive, sine negative. All students take calculus. Here everything is positive. Here only sine is positive. Here only tangent is positive. Here only cosine is positive. So it's in fourth quadrant. Because my cosine is positive and sine is negative. And I know, sir, what do you call? For 30 here, for 30 degrees here, I have sine as 1/2 and cosine as root 3 over 2. So if I need to find in this quadrant my angle, how do I find it is from 360 I subtract 30, which is basically 330 in degrees. If I have to convert into radians, convert 3 into radians, how do you do it? Times pi over 180, which is basically, they cancel, you get 11 pi over 6. So basically my theta is 11 pi over 6. Anyone has any problem how I got this 11 pi over 6 as my theta?
Yeah, yes. Can you go over that again?
Okay. Even if you look at your unit circle, don't stress about this. Look at your unit circle. Does everyone have a unit circle in front of them? Or you want me to draw a unit circle?
No, I have one.
Okay, you have one. So can you tell me where on the unit circle you have sine as negative 1 over 2 and cosine as root 3 over 2. So basically your x is root 3 over 2 and your y is negative 1 over 2. Can you see and tell me where is it? You found it, Christopher, or no?
Oh, what?
Oh, wait. Who asked me the question? Angel. Angel, did you find it or no? On the unit circle.
Oh, sorry. You're glitching in and out on me. I can't quite hear you.
Okay. Let's see. So, Evan, let's draw the unit circle. I want to draw the unit circle so that you guys can see. Okay. This is what my unit circle was. Okay, this is my 30 degrees, 45 degrees, and this is 60 degrees, this is 90 degrees, and this is 120 degrees. And this is 150. Okay, and then you have here, and similarly you will have here. So this was your unit circle. So here you had here, if you see, the value was root 3 over 2, 1 over 2. This was 1 over root 2 over 1 over root 2. And this was basically 1 over 2, root 3 over 2. This was 0, 1. This was 1, 0. This thing was negative 1, 0. This was 0, negative 1. And here you had root 3 over 2, negative 1 over 2. Similarly, like this you had, and if you calculate, this was given to you as 330 degrees. So I'm looking for, in my question, I'm looking for my sine as negative 1/2 and cosine is root 3 over 2. Note, sine tells me the second one and cosine tells me the first one. So that means cosine tells me the x coordinate, sine tells me the y coordinate. That's what I have to check here. For what value I have x as my root 3 over 2 and y as my negative 1/2. And that is for 330. When you look at a unit circle, which is basically 11 pi over 6. Once you found that, put in the formula. The formula for polar coordinate for complex is r cosine theta plus iota sine theta. We found our r was 2, it becomes 2 cosine 11 pi over 6 plus I sine 11 pi over 6. That's it, that's your answer. Anyone else, any question about this thing? You basically need to know how to find your r and how to find your theta. Let's do example. Let's do an example on this. So 13 questions. Okay.
Was that 2? Is that I, or is it cosine theta plus sine?
Plus
I theta?
I sine theta.
Oh, okay.
I sine theta. I want you to convert this 1 plus I into polar form. So you're given z is equal to 1 plus I, convert into polar form. Same steps. You have to do the same steps. Carly here. Jelena. Axel. Alejandro. Jose.
Yeah.
Okay. How do you find the polar form for this one?
So if I'm looking at that right, it only gives you your x, correct?
Yes, x is?
That's 1.
Okay, y is?
1.
Okay. How do you find your r?
You're just going to do x squared plus y squared equals r squared, which is the square root of 2.
Yeah, so you get r as square root of 2, correct? So basically, how did you get s? You got 1 square plus 1 square. Okay, perfect. How do you find your theta?
So if you already have your x and y, and the cosine and sine are x over r, y over r, you're going to have 1 over root 2 for both.
Okay. For what value are both 1 over root 2?
I don't think any of them are.
Root 2 over 2 and 1 over root 2, they are the same thing.
Oh, okay. So are they both positives? So it should be on the first
Yes,
pi over 4.
pi over 4. Perfect. So what's my final answer?
Is it? So are you gonna have to give that formula z equals r cosine plus I sine theta?
Yes.
So z equals square root of 2 cosine pi over 4 plus I sine pi over 4.
Perfect. That's a final answer. Correct. Really good. Anyone has any questions how to convert the complex number into polar form?
Yeah, I'm not really getting where the I is coming from.
This I?
Yeah.
This
Like,
I is in the formula. That's a general formula for the complex. So right now we're talking about complex numbers. In complex numbers, you always have iota. That's what complex numbers are. They have imaginary terms. And now in this topic, especially 9.3, what we are doing is we are trying to deal with just complex numbers. We are converting complex numbers into polar form. So in polar form also you will have I, because it's a complex number. Are you getting it, Angel?
Yeah, I just didn't hear that last part. You said it cut out.
Yeah, it is. So basically this I is in the formula. Whenever you are dealing with complex numbers, you will always have an iota.
Okay.
Yeah. Okay, let's do one more here. So some of the properties, if you want to write it, it says if you're given two complex numbers. First one I'm calling it as z1, which is r1 cosine theta 1 plus I sine theta 1. This is one of your complex numbers. Okay, and you're given a second one, which is r2 cosine theta 2 plus I sine theta 2. And if I say multiply these two, and if I say you have to multiply these two complex numbers, how you're going to multiply is you're going to multiply their r's, so it will become r1 times r2, but it will become cosine, but you're gonna add their theta, so it will become theta 1 plus theta 2 plus I sine theta 1 plus theta 2. That's how you multiply them. So if you're given two complex numbers in polar form, note they are in polar form, and I say multiply them, how you're gonna multiply it? Multiply the r's, it will become r1 times r2, but you're gonna add the thetas. You're not gonna multiply the thetas, you add the theta, so it becomes theta 1 plus theta 2 plus I sine theta 1 plus theta 2. And if I want you to divide, divide the r's. Whatever you are doing, you're gonna do the same thing with r's. If you're multiplying, you're gonna multiply r's. If you're dividing, you're gonna divide r's. But now in this case, you're gonna subtract the thetas. So it becomes theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So in division, you subtract the angles. In multiplication, you add the angles. Example, if you are given z is equal to 3 cosine 20 degrees plus I sine 20 degrees, and you're given w as 5 cosine 100 degrees plus I sine 100 degrees. This is I sine 100 degrees. Okay. What I need to find is z times w. And one die?
Yes.
I'm given two complex in polar forms. I need to find z times w. Can you help me multiply?
Okay, so so R1 would be 3.
Mm-hmm.
R2 would be 5.
Okay.
So they would be multiplying.
Yes.
So that would be 3 times 5. In parentheses would be cosine 20 degrees plus 100 degrees.
Perfect.
And then it'll be plus I. Is it
Yeah,
I sine?
yes.
I sine 20 degrees plus 100 degrees.
Comes out to be cosine what?
That would be 15 cosine 120 plus I sine 120.
Correct. That's it. Good. Very good. if I say you have to find z over w, you have to divide z by w. Daniel?
Yes.
Okay, Daniel. Now we have to divide.
Okay, so it will be 3/5.
Mm-hmm.
Then it's cosine 20 minus 100.
Mm-hmm.
Then it will be plus I sine 20 minus 100.
Which comes out to be what?
Then 3/5 cosine 80.
Negative 80.
Well, negative 80 plus I sine negative 80.
Okay, I don't want to leave negative 80. I don't want to leave as a negative angle. I want my angle to be positive. Negative 80 means
Okay.
from here I'm going 80 degrees, right? And I reach somewhere here. Correct, Daniel?
Mm-hmm.
Okay,
Yes.
this is 80. But I want positive. This is negative 80. How do I convert into positive? If I have to measure from here to here, how much is it?
From where to where?
From this,
Also, it will be you have to add like
We subtract it from 360.
yes. This much is 80, right?
so you,
So, and this whole thing is 360, right?
yeah,
So,
360 minus 80.
which is
It will be
280.
60 to 80.
280. So, you always have to leave your theta in positive between 0 and 360. Your angle should be between 0 and 360, and R should always be positive. Good. Let's do one more problem here. Anyone has any question how to multiply and divide? No? Okay. So let's do one more problem on this. So you are given z as 2 cosine 40 plus I sine 40 degree, and w you are given as 4 cosine 20 plus I sine 20 degrees. Gerald?
So we multiply this one, correct?
Yes, multiplying.
Okay, so that would be z times w is equal to 2 times 4,
Mm-hmm.
parentheses cosine,
Mm-hmm.
40 plus 40,
40 plus
or
40?
40 plus 20, I'm sorry.
Yes.
And then plus I sine,
Mm-hmm.
40 plus 20.
Which becomes?
And then you'll get 8 parentheses cosine, 60 degrees, plus I sine, 60 degrees.
Good. Really good, Gerald. Joshua?
Yeah.
Okay, what about z over w? Divide them.
Z over W would be 2 over 4
Mm-hmm.
cos 40 minus 20
Okay. Plus I sine
plus I sine 20 minus 40.
20 minus 40?
40 minus 20.
Yeah, 40 minus 20. Which becomes?
1/2 cos 20 plus I sine 20.
Perfect. In this I don't have to change because both of my angles are positive and between 0 and 360. Really good. Next and the last theorem we are doing is, next and the last theorem says is of his De Moivre's theorem. So if you are given De Moivre's theorem, it says if you are given z as r cosine theta plus I sine theta, then if I say find z to the power of n, note it's in polar form, and I say find z to the power of n, how you're gonna do it is you will raise your r also to the power of n, but it will become cosine. You're gonna multiply your theta with n. It becomes n theta plus I sine n theta. If you have raised to power n, you're gonna multiply your n theta with n.
So what was the theorem again? What was it called again?
De Moivre's theorem. De Moivre's theorem. M-O-I-V, this is R-E-S. De Moivre's theorem. Okay, example. If it says write 2 cosine 2 theta plus I sine 2 theta to the power of 3 in the standard A plus IB. So now you're raising this whole thing to the power of 3. You will not just distribute 3 like this and multiply. No. Okay, when you do raise to power 3, it will become 2 to the power of 3. But you have to multiply this 3 with 20 here. So it becomes 3 times 20 degree plus I sine 3 times 20 degrees. And when you solve, it becomes basically 8 cosine, which is 60 degrees plus I sine 60 degrees. But note the question is saying you have to convert into A plus IB. They don't want in cosine or sine. So you have to simplify. Cosine 60, 1 over 2 plus I sine 60 is root 3 over 2. When you open the bracket, it will become 4 plus I 4 root 3. Since they're asking you to convert into A plus IB, you have to simplify. Just plug in the values of cosine 60, sine 60 and simplify. You will get in the general form. So let's do an example here. So your example is, so you are given, you have to find in standard form, you have to convert into standard form A plus IB. You are given, you have to find 4 cosine 40 degrees plus I sine 40 degrees to the power of 3. The power of 3. Christopher?
Not really sure how to start this. Hello?
Hello, Christopher?
Hello?
It's okay. Angel?
Yes.
Yeah, so let's do this one. I want you to convert into general
One
form.
second. So we're just using the same principles as we did before.
Yes.
So it'd be 4 to the third power.
Yes, correct.
4 to the third power, parentheses, cosine. Do we put it to the third power, or should we just calculate it now?
No, you don't put to the third power. Well, how do
Oh,
you?
we don't?
Yeah, see, what's the formula here? De Morgan's theorem. See, what does it say? When you are raising it to the power of n, you raise r to the power of n, which you did. You raised your r was
We multiply it. We
Yes.
multiply the
Exactly.
40 to 3.
correct. Similarly, with sine also you do the same thing.
Oh, it's frozen.
With sine also you do the same thing. Can you hear me, Angel?
Yeah. It's just you're cutting in and out for me.
Oh,
Uh,
Okay.
so-
so what does it become?
Oh, then it becomes the. It becomes the 64
Cosine
cosine 120.
plus I sine 120. Can you tell me what's the value of cosine 120?
So it's 2 pi over 3. Oh wait, sine or
Cosine.
cosine. It's negative 1/2.
Negative 1/2 plus I sine. What is sine 120?
Root 3 over 2.
Root 3 over 2. Correct. Okay. Let's simplify. If I multiply 64 with negative 1/2, what do I get?
You multiply that?
Yes, you have to distribute, right?
Oh yeah. Negative 32, right?
Yes. Negative 32 plus, here you have I. What is 64 root 3 divided by 2?
Uh, 32 root 3.
Correct. That's your answer. Really good, Angel.
Wait, I have a question.
Yes.
How do you get the I-32 particle there?
So basically here, did you get till here, Samantha?
Yes,
Yeah.
yes, I get everything.
And then we simplify this thing, so it becomes basically when you multiply, it's 64 over 1. When you multiply, you just directly multiply like the, across, and it becomes 64 I root 3 over 2. And then if you divide 64 by 2, it comes out to be 32.
Oh, 32.
That's how you got 32 root 3.
Okay, I get that now.
Yeah.
Thank
Okay, perfect. Yes. Next thing is, okay, so far what we were given is, we were given in polar form. Note, we were given in polar form. This was polar form, and polar form was raised to power something. Polar form was raised to power something. But now in the next example, this is combining everything. This is combining everything you are doing so far. It says, write 1 plus I to the power of 5 in the standard form. 1 plus I in the standard form, A plus IB. You have to convert this into standard form. Okay. Note, you cannot just use the formula De Morvis theorem. You cannot use the De Morvis theorem directly because it has to be in the polar form. It has to be in the polar form. The initial question has to be in polar form. If it's not in polar form, first you're going to convert into polar form, then you're going to use your De Morvis theorem. So I need to convert this. So if my z is 1 plus I need to convert this thing into polar form. Samantha?
Yes.
How do I convert this into polar form?
So x is 1 and y is 1.
1. How do you find your r?
So it's r squared equals x squared plus y squared.
Yes, x squared plus y squared. Get.
So it's 1 to the power of 2 plus 1 to the power of 2 again. Which gives me r equals radical 2.
Yes, perfect. You get r is equal to radical 2. How do you find my theta?
So it's sine theta y over r.
Which becomes?
And cos is x over r.
And what's your y and r?
So 1 over radical 2, and for your cosine, for your cos is 1 over radical 2 again.
So you look at your unit circle, Samantha, and tell me for what angle, for what theta. I have sine as 1 over root 2 and cosine also as 1 over root 2.
Okay, so for sine 1 over 2, so sine is for y, so
both should be x and y, both should be 1 over root 2. Root 2 over 2 and 1 over root 2, they are the same thing. Your x and y both should be root 2 over 2.
Oh, 2 over 2?
Yeah.
Oh, okay. Okay, so that's 4 pi.
It is what? Pi over what?
4.
4. Yes, 45 degrees. Guys, if you want to make a note for yourself, 1 over root 2 and root 2 over 2, they are the same. It's just that you rationalized. So to get rid of the denominator, square root in the denominator, you rationalize. Technically, it means the same.
Okay, so whenever I get 1 over radical 2, it's technically
root 2 over 2.
Okay.
Yes. So what does it become if I write in complex form? What does it become?
So it becomes x equals radical 2. Then parentheses goes pi over 4 plus I sine pi over 4.
Correct. Really good, Samantha. Is Shaira here?
Yes.
Okay, Shaira. I converted into polar form, but now I need to find to the power of 5th. This whole thing to the power of 5th. How do I do it?
Root 2 to the power of 5.
Okay.
Then times cosine times 5 times, I put it to degree 45.
Okay, no problem.
Plus I sine 5 times 45 degrees.
Okay. When you convert, what is root 2 times 5?
I was doing that right. Sorry.
So root 2 over 5 means you're multiplying root 2 5 times.
And got 4 root 2.
Yes, exactly. 1 will give you 2. These 2 you'll multiply, you get 2. So you get 4 root 2. Cosine what? 5 pi over 4 plus I sine 5 pi over 4. When you multiply in degrees, what did you get? Shaira?
Sorry. 225.
5 times 45. Yes, 225.
225.
Yes. So what does it become? Cosine, when you put in the values, what does it become? What is cosine of 225?
Sorry, what was that?
What's the cosine of 225?
Negative root 2 over 2.
Okay. Plus I, what's the sine 225?
It is the same thing.
Negative root 2 over 2. Okay. Now let's distribute. You have to open the bracket.
Sorry, I'm just writing it down.
Yeah. It's okay. Take your time. Yes, Samantha. You have question?
No, sorry, I forgot I was not on mute.
Okay. Shara, did you distribute?
Yes, I'm doing that right now.
Okay.
Is it negative 8 plus 4 root 2i?
So basically what you get is here, when you multiply, you get 4 root 2 times negative root 2 over 2 plus I 4 root 2 times negative root 2 over 2, right? Okay, let's see. So you have 4 root 2 times negative root 2 over 2. Let's simplify first this thing. Shaira, what is root 2 times root 2?
What was that? Sorry.
What is root 2 times root 2?
Oh, 2.
So you get 4 times 2 over 2, which is negative 8 over 2, which is what?
Negative 4.
Yes. Let's solve the other one. So you have you had 4 root 2 times negative root 2 over 2. So it becomes negative I. What is 4 root 2 times root 2?
4 root what?
4
Sorry.
2 times root 2.
8.
8 over 2, which is
4.
4. So you get minus I. 4. This is your answer. Okay. Let's see if there is some question. Okay. I want everyone to do this problem here. So you have to convert. This is the last problem here. You have to convert root 2 minus I to the power of 6 into standard form A plus IB. This is the last problem we are doing today. Karen?
Yes.
Okay, Karen.
So x is equal to root 2
Okay, and y is?
and y is -1.
Okay. How do you find your r?
R is root 2 square plus -1 square. 2 plus 1 root of 3.
Yeah, root of 3. Yes, you get r as root of 3.
Sine is y over r and -1 over square root 3 and cosine is x over r and is root 2 over root 3.
Okay. For what value is my sine -1 over root 3 and cosine root 2 over root 3? There's, you don't know like standard form, right? The thing is, in your book, is it? Just a second, give me a second. Is it? Teaching you. I'm not teaching. Okay, so you can use your calculator to find it.
Okay.
Since it's not direct. Right.
Is it the inverse?
Yes, inverse, yes.
Inverse. And over
Sine inverse, you have -1.
Oh, we use inverse sign in this case?
Yes, because the thing is, it's not direct, right?
Yeah, yeah, so it'd be rewritten as theta equals inverse
Yes.
sine -1 over 3, root 3.
Yes. -1 divided by square root of 3. So you got what? Theta is what?
negative 35.26.
Yeah, 35.26.
Mm-hmm.
Okay. So what happens here? When you put in angle, what do you get?
Okay. C is root 3.
So you get Z is equal to what?
Root 3 multiply cosine -36.26
plus I sine -35.26.
I sine. No.
Yeah. You got this thing, right?
Mm-hmm.
Okay, now what you have to do?
To the bottom of 6.
Yeah, you have to see, since you have to find 6, what do you get?
Root 3 to the bottom 6. Cosine 6 multiply
negative 35.26 plus I sine 6 multiplied negative 35
0.26.
2. Yes. Then hmm, 27 cosine 6 25. Cosine of negative 11.56 plus I sine this negative 11.56.
Okay, so what is cosine negative 211.56?
Is cosine is 27.
Did you find an answer?
No.
So here, see, you practice.
Cosine is negative 0.85. Right?
Negative 0.85
Plus
plus
8
plus I. What is sine?
plus sine is 0.52.
Yeah, 523. Okay. And when you multiply, distribute, can you tell me the answer?
Is
That's not negative?
Oh, it's yes.
no.
Okay.
It's not negative, yes.
Negative 22.95.
Okay. Plus
I 40.04. No, 14.
14.13. Yes.
0.
04?
Oh, yes. 40.
Isn't it
1
20?
to 1.
When you're multiplying these two, didn't you get 22.95? You're getting 32.95? It's 22.95. You're getting this thing as an answer.
Yeah, that's what I got.
Yeah, that's what you're supposed to get.
Yes. Okay.
Is Axel here? Alejandro? Jelena? Carly? Okay. So this is it for today, guys, but you have your exam tomorrow. So definitely you're going to get a question on, I'm definitely telling you, you're definitely going to get a question something related to this. Converting, so De Morgan's theorem. You're definitely getting question on De Morgan's theorem in your exam tomorrow. You will also okay, let me see if I can. Do you want to take exam tomorrow, or you want me to start the new topic tomorrow, or you want to take the exam tomorrow first and then I can take the exam on Monday.
I suggest we should do the exam on Monday.
Yeah, so that if you have questions, you can ask me tomorrow. So I'm going.
For me, I think it's a bit too early to have an exam already after last week's exam.
Okay, so you will have your exam on Monday for this chapter number 8 and chapter number 9. Okay, but you will have quiz for chapter number 9 on Friday. You will have quiz on chapter number 9 on Friday, and you will have your exam on Monday. And tomorrow I'm gonna start with another chapter, which is chapter number 10. That will not be included in your test, this coming test.
Oh, that makes more sense to have the quiz before the exam.
Yes, quiz before the exam, yes, so that you can practice, yes. Any other questions, anyone? Okay, thanks guys, see you tomorrow.
Bye.
Take care, have a nice day, take care, bye.
Bye. Thank you. Have a nice day.
You too, have a nice day.
I just have a quick question.
Yeah.
So sometimes when you don't send the